Continuing yesterday's lesson, go ahead and work on example 1, part A and B there. Okay? Still in our 11.3 here. Okay, so if you recall from yesterday, our formula one half diameter 1 times diameter 2, so it's 1/2. This diameter is 6, that diameter is 8. So 1/2 of 6 times 8, so a quick way of that, take half of one of them, that's 3. 3 times 8 is 24. Area is 24 square meters.
Is it the same for a kite?
Same thing for a kite, yeah. Okay, half of 10 is 5. 5 times 7 is 35. All right. Oops, that's centimeters. Okay. If you need more practice on those, I've included the monitoring progress there. You can do those, but I'm not going to cruise through those. Any questions on example 1? Hopefully that was pretty quick and easy if you remember our formulas. Move on to example 2. Okay. I want you to go ahead and work through that problem there with your groupies. So, you have a pentagon. If I'm trying to find AFB here, hey, rocker monsters, why don't we turn that on? There we go. So we've got 360 degrees divided by, there would be 5 congruent triangles there, so each of these angles are the same. So if I'm going A to F to B, that's divided by 5, which is 72 degrees. Okay, and AFG is half of the 72 degree angle, so AFG is right here. So that angle is 72 divided by 2, or 36. And GAF, G to A to F, that completes our triangle. We got 90 and 36 plus GAF. So these two, the 36 plus GAF, has to equal 90. So 90 minus the 36 we already have gives us 54. All right. Using the triangle angle sum theorem there, dealing with this triangle. All right. Any questions there? Once again, I included some more practice problems on the bottom if you want to try them a little later. Check them out. Let's move on to example 3. Kind of building in here, regular nonagon is inscribed in a circle with a radius of 4. Find the area of the nonagon. Okay? Nonagon meaning how many sides? 9. So the number of sides is 9. Okay, use your formula that we talked about yesterday to help you out. Okay, work together there. So area equals 1/2 AP, A being the apothem, which in this case is right here. P being your perimeter is here. So if we look at that triangle and just kind of pull it out there, we have a length of 4, we have a right angle, and if this is 4, and we can find this measure right here, okay, the measure of that angle would be, well, first this whole angle would be 360 divided by 9, which is 40. Good. And then half of that is the 20, and that 20 is this angle right here. Okay. Do we know this length? How could we calculate it? SOHCAHTOA. Okay. So tell your neighbor what you're going to use to find that there. Okay, so this, let's give these some letters. That's L, that's K, and we'll call that M. Okay, So to find this, which will help us to find a side length, okay, I'm trying to find this side right here. So this is our opposite side of our angle and our hypotenuse. So opposite and hypotenuse is sine. So the sine of 20 is equal to this side, let's call that x, x over 4. So x is equal to, cross multiply, 4 sine 20. Now that is a half of this entire side. So how many 4s is it going to make or take? How many 4 sine 20s is it going to take to make up an entire side? 2 of them. So a grand total of, this side length is 8 sine 20. Okay, so if that side's 8 sine 20, and there are 9 of those, the perimeter is equal to 9 times 8 sine 20. The apothem, well, that's this one. If we call that y, what trig ratio am I using to find y? Let's not use the Pythagorean theorem because we'd have to use a rounded value or just a messy. But we could use cosine, yeah. Cosine of 20 is equal to adjacent over hypotenuse. So y over 4. Which means the apothem there is 4 cos 20. That's this here. Remember, that's our apothem. So we end up with 1/2, and then a is 4 cos 20. So this is what we're putting into our calculator to find our area. Make sure, by the way, if you're borrowing the graphing calculators from this classroom, you check the mode every day. Trig is using radian measures right now, which you're using degree measures. So if they're using radians and you're using degrees and you're using the same calculators, then we have issues. Anyone got a rounded amount for me? Yeah.
It's like 46.
Yeah, 46.28 or 46.3 if we round it up. Good. All right. Bit more complex when you're dealing with sine and cosine, right? So if you're struggling with that one at all, a good practice problem for you to try is this one right here, because you'll have to use it as well. It's number 6 on the bottom. Before we do that, I want to try... Oh, actually, are there any questions on what we did on this one? Yeah, Drew?
Why didn't you use tangents cosine?
I don't know either the adjacent or the opposite. Like, are you talking for... You're talking for this one?
So after you did sine.
Right. I could have used tangent if I wanted to use another trig function within that ratio. So tangent would have been... it would have been 4 sine 20 over y. And that would have made this become 4 sine 20 tan 20. It would have been a trig function within a trig function. It's just uglier. That's why I didn't do it. Okay, and I don't want to use a rounded number, so that's why I kept it with cosine. Maddie?
I was using my calculator, like the exact same way, and I got 127.
You got what?
I got 127.15.
And did you use 9 times 8 here?
Yeah.
So you have 72 sine 20?
Yeah.
Huh.
Yeah.
Okay. Can you just go to your mode and make sure it says degrees? Okay.
I got the same thing. It's just you probably did the order of operations wrong. Because the 1/2 would have been like 1/2. It would be 1 divided by everything else.
So Maddie, you've got it in like this here?
I did this way.
I'll come over and check yours out, okay? If you haven't figured it out. So, thank you. All right, last one. Try example 4. Okay. Your apothem drops down there, and if this is regular, that means this is 15 for this entire side, which means if I pull that triangle out there, this is half of 15, or 7.5. Okay, and then we can use the Pythagorean theorem here. They've given us values. So you have, to find your apothem, so you'd have a squared is equal, or a squared plus b squared, or equals c squared. And we have a squared plus, what is that, 70, so 5625. Anyone have that? I think that's right. No, 56.25. So we do 7.5 squared, I think. And 19.6 squared. What's 19.6 squared?
384.16.
Thank you. All right, and so a squared then, we subtract those out, we should have
27.91.
A is approximately 18.108. So that's our apothem. So area equals 1/2. If you want to do an exact value here for apothem, you just do the root of this, 327.91. That's the actual exact value of our apothem. And then times the perimeter of 15 times 8. So there's our A, there's our P. Equals to 1/2. Actually, I just multiply all that out. Okay. It rounds to 1,060 or 1,086.5 square inches. Good? Any questions? So the problems get a little more complex from just the very basic. I mean, you have to use your trig functions. You'll have to use the Pythagorean theorem. So all those tricks you have, okay? And then you have obviously the very basic stuff, okay? All right, very good job.